In the sixth section of this unit, we're going to go through solving an equation by completing the square. So this is a more complicated topic in this unit, so we're going to break it up into 2 days. In this video, we're going to go over 2 topics to kind of introduce this and review kind of the important algebra topics that are going to make completing the square a little bit easier. Our goals in this video are going to be to review simplifying radicals as well as solving an equation that has square roots. So first, for simplifying radicals, what we want to do here is we're going to look at a square root and we're going to think, can this reduce anymore? What that means here is we're going to extract the largest square root or perfect square from under the radical. In the first example we're going to look at is the square root of 75. So when I look at this number, what I'm going to want to think in these kinds of problems is there any perfect square that I could pull out of 75? As a reminder, and we'll put these on the board, let's go through our perfect squares 1 through 10. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 times 4 is 16, 5 squared 25, 6 times 6 36, 7 squared is 49, 8 squared 64, 9 squared 81, 10 squared 100. The list goes on. As you're doing these problems though, if you know the perfect squares of 1 through 10, you should be good to go. So after I see my list, I want to ask myself, is there any perfect squares that go into 75? Or what's the biggest perfect square that can go into 75? Looking at this list, I could see that 25 goes into 75. So how I can rewrite the square root of 75 is I could say it's a product of 2 irrational numbers. I could say the square root of 75 is equal to the square root of 25 times the square root of 3. Now what I can do from here, since 25 is a perfect square, the square root of 25 is just 5. So I could reduce this to say that this is equal to 5 times the square root of 3. I know that this is simplified because what's left under my radical is 3. And looking at this list, 3 is a prime number. There's no perfect square that goes into 3. So from here, I would be done. If you want to double check this, you could plug into your calculator the square root of 75, and you could plug in 5 times the square root of 3. They're both going to give you the same number, so you know you'd be good to go there as well. The next example we'll look at is the square root of 15. The square root of 15, I'm going to ask myself again, is there any perfect square that goes into 15? Looking at my list, none of them go into it. I have 1, 4, 9, and by the time I get to 16, my number's too big. So if I see something like the square root of 15, I can tell myself, okay, that's already simplified. I don't have to do anything from there. Another example you might see is the square root of 100. Now the square root of 100 is a perfect square, so this would simplify to just be 10. Now I'd be good to go there. So this is simplified. This is a perfect square, so it's going to simplify to a whole number. And as a recap, this would simplify to be 5 square root of 3. The next thing that we're going to look at in this video is finding square roots. So here, let's look at an example problem. We have 4x squared plus 10 equals 46, and I want to know what is the solution or solutions to this equation. So similar to any other algebra problem, what I'm going to want to do here is get the x by itself. So what I'm going to do first is I'm going to subtract 10 on both sides. From there, I'm going to want to divide both sides by 4. And finally, I have x squared equals 9. To get the x by itself, what I'm going to have to do is square root both sides. And what happens here, when I do that, I'm going to be left with x equals positive 3 or x equals negative 3. I say this because as I work backwards, I don't know if positive 3 or negative 3 gave me my answer. Both of these solutions would work because negative 3 squared and 3 squared both give me 9. One way you could double check this is plugging in 4 times 3 squared plus 10. That would give you 46. 4 times negative 3 squared plus 10 would also give you 46. So as you can see here, both of these answers would be solutions. So I have a positive root and a negative root. Let's look at one more example. Here I have 3x squared minus 5 equals 25. So what I'm going to want to do here is, again, get x by itself. And then I have 3x squared equals 30. Divide both sides by 3. I have x squared equals 10. Here, I'm going to want to take the square root of both sides. Since I'm taking the square root, I have a positive and negative answer. X equals plus or minus the square root of 10. And I'm done.